Hey everyone, welcome to my channel. In this video we are going to learn how to perform facial recognition with high accuracy. We will first briefly go through the theory and then learn the basic implementation. Then we will create an attendance project that will use webcam to detect faces and then record the attendance live in an Excel sheet. I upload videos on a weekly basis, so don't forget to subscribe and give this video a thumbs up if you find it useful. So let's get started. So today we will be using a face recognition library to actually recognize our faces and differentiate between different people. Now, before we start with the implementation, let's have a brief look at how this library works. So here we have an article written by the author himself. His name is Adam, and we will have a quick look at it so that we can understand how the backend works. So there are a couple of steps required to perform this facial recognition. So the step one is actually finding the faces, and they are using the HOG method at the backend, which is histogram of oriented gradients. And once we have the this is a sample of HOG, and once we have the face, that is the bounding box where the face is present, then they apply a warp. Because for example, if you look at this is a frontal image, and if you look at this is a little bit tilted, and for the network to understand a human, this will be completely different than this. So what they do is they try to make all the images look something like this. So they use the dlib library at the backend. If you want to know more about dlib and how it works, I have a tutorial on that. You can check it out in the description. So what happens is that they find the facial landmarks, and using these landmarks they actually warp the image so that it looks more like this. So it is more centered. And once they have this image, they will send this to a neural network which is previously trained. And what that does is that gives us the encoded features. Now, what are these features? Now, as a human, this is a good example. As a human, if you think about this, it might be the measurement might be the difference between your eyes, the distance between your nose and the lips, the size of your lips. You know, these are the things that you might think of. But for a network, it automatically trains itself to find these best measurements. So that is what the network has done already. So what it does is, for us, we only feed in the image and it will generate 120 different measurements for us. So for example, for this image, you can see that this was the input image and it generated these 128 measurements. Now, using these 128 measurements, we can define a person. And using these measurements, we can differentiate between different people as well. So the last step is to differentiate them and to find the matches. So to do that, you can, as you can see, these are simple numbers. You can use any machine learning method. Over here they have used SVM classifier, the linear model of it, and using that they can differentiate between these measurements, and they can tell whether the measurements are of the given person or not. So that is the theory, the brief theory. And if you want to learn more about this, I will leave this link of this article in the description. Now, before we can use this library, we have to install the C compiler. Now, if you go to the Visual Studio website, in the download section, we can download the community version for this. Now, once we download that, we will have something like this in our installation. And what we have to do is we just have to select the desktop development with C++. So that is the only thing that is required. So once we install that, we can come back to our PyCharm project and we can install the dependencies. So let's go to File, Settings, and then we will go to the project interpreter and we will add the dependencies. Now the first one is CMake, so we will write CMake. We will install that. Then we have dlib. Now I actually face some issues with the dlib library, and I will not recommend using the latest one as it yields a lot of errors. So what I recommend is to use 19.18. So we can install that. Then we will install face recognition. Then NumPy, and the last one is OpenCV. So once they are done installing, we are going to import them. So the first one will be import CV2 and then import NumPy as np, and then we will import our face recognition library. So import face recognition. So we saw that there are a lot of steps that we have to perform to actually do the facial recognition at the backend, but because we are using this library, we just have to call a few functions to run it. Now what I have done is I have broken this down into 3 steps, and we are going to look at step by step how we can use this library. So the first step is basically loading the images and converting it into RGB, because we are getting the image as BGR, but the library understands it as RGB, so we have to convert it. Now if we look at our directory, we have images basic. Now we are running the script basics, so that's why we are using this one. What we have here is 2 images of Elon Musk and 1 image of Bill Gates. So if we open up, this is the image of Elon Musk, and then we also have a test image for Elon Musk, and then we also have a test image for Bill Gates. So what we will do is we will train, we will get the encodings of our normal image, and then we are going to use the test image to see that if it can find the picture of Elon over here or not. So coming back to the steps, the first thing we will do is we will import our image. So we will write image Elon is equals to face recognition dot load image. So it gives us a function to load images, so that's why we are using this. So we have image basic, and then we have Elon Musk. So then we will convert this into RGB. So we will use cv2.cvt color, and then we will write image Elon, and we will write cv2.color BGR to RGB. Then we can write cv2.im show, and we will give it a name. So we will say Elon Musk, and then we will write image Elon, and we will write cv2.waitKey, and we will give a delay of 0. Similarly, we are going to import our test image. So we will copy this, and over here we will write image test. We'll copy this and paste it, and we will change this to Elon test. So then we can copy this again, and we can paste it here, and then we can write here test, and this one is test as well. So if we run this, and there we have our 2 images. So this is the test image, and this is the normal image that we will use for encoding. So this was step 1. Now the step 2 is finding the faces in our image and then finding their encodings as well. So to do that, we will first detect the face. So we will say that face location is equals to, let me write face location is equals to face recognition dot face underscore locations. And all we have to do is we have to send in an image. So we will send in image alone. And because we are only sending in a single image, we will just get the first element of this. Then we are going to encode the face that we have detected. So we will write encode elon is equals to face underscore recognition dot face encodings, and then we are going to send in our image, which is image elon. We'll say the first element here as well. And the face locations are right now we are just doing it so that we can see where we have detected the faces. So to see that, we can write cv2 dot rectangle and we can draw it on image elon, and then we have to give the location of the face. So now for the face location, it actually returns us 4 values. Let me show you. So let's print this out. So there you go, you can see that it prints out 4 different values. These values are basically top, right, bottom and left. So based on that, we can give the x1 y1 and x2 y2 in our rectangle. So we will go back here, and then we are going to write the first element will be face at 1 face location, and then the second one is face location at 2, and we will copy this, and these are the second points. So this will be, actually this will be 3 and 0, 3 and 0, and that will be 1 and 2. And then we have to define the colors. So the color, let's put it purple, and then we can define the thickness. Let's run this and see what happens. And there we have it. So now we can see that this is the face that we have detected. The same thing we can do for our second image, which is the test image. Now in this example, we do not need the face location. All we need are the encodings. The face location we are just doing so that we can see where the face is located and whether it's located properly or not. So we can write here face location test, and then image test, this again test, or let's remove the elon, and then image test, and this we will have to replace. Let's run that again. And there we have it. So now we're detecting both the faces in both the images. Now so far we have done 2 steps. Now we are moving on to the third and the final step. The third step is basically comparing these faces and finding the distance between them. So as I have mentioned before, we are getting the encodings, so the encoding for elon and the encoding for the test image, and then we are going to compare these encodings. So these are 128 measurements of both the faces, and what we will use at the backend is the linear SVM to find out whether they match or not. So let's write it down. So we will say that results is equals to face underscore recognition dot compare faces, and we have to give in a list. So we don't have a list at this point, so we are just this is the list of the known faces. So right now we have only one face, which is Elon, so we are going to use that. So encode Elon, and then we are comparing it with which encodings. Encode test. So if we print this out, we will find our results. So let's run that. And there you go. So as you can see, it gives us a value of true, which means it has found these both encodings to be similar, so they are of the same person. But what if we change the test image to Bill Gates? Bill Gates. Let's run that. And there we have it. So it detected the face properly, and then it is telling us that this is false, the encodings do not match. So this is good. But sometimes what happens is that you have a lot of images and there can be similarities. So what you want to find out is how similar these images are. So you might want to find the best match. So to do that, we will find the distance. So we will write here face distance is equals to face underscore recognition dot face distance. And again, we have to give in a list, so we don't have that, so we will write just encode Elon and then encode test, and this will give us the distance. Now the lower the distance, the better the match is. So if we print the distance as well, so we can write here face distance, and let's run this. So here we are getting a value of 0.84. And if we change this to Elon, then we are getting a value of 0.43 or 0.44. So you can see that there's a clear difference when they actually match and when they don't match. So the final step we can do here is just to display this on the actual result image. So we can write here cv2.putText, and we can put it on the test image. What we want to put is basically our results. So we can write results, and we also want to put in our the face distance. So face distance, the distance is it's in decimal places and it's very long, so we can round it off. So we can say round to 2 decimal places, and then we can give in the origin. Let's put 50/50, and then the color, no, not the color, the font. So cv2.font, let's put any font, and then we have the scale, which we'll put as 1. Then we have the color, let's put it as red, and then we have the thickness, let's put it as 2. So let's run. Okay, we are facing a problem. Yes, because this is an array, it's not a value, so we have to get the element. So we are talking about the first element of this. And there you go. So right now it's showing that it's true and it's 0.44. And if we go back and we change this to Bill Gates, Now this gives us false, and it gives us a value of 0.84. So next we are going to create an attendance project based on this facial recognition library. So let's go ahead and create a new file. We will call this attendance project. And what we will do is we will first import our libraries as we did before. So let's copy that. So now let's look at the steps. The first step is again to import your images and then convert them into RGB. So this is the first step. Now, but if you look at this, whenever we have to bring in a new image, we will have to write it manually, give it a name, and then store it and find its encodings. That will be a very messy process. So what we can do is we can create a list that will get the images from our folder automatically, and then it will generate the encodings for it automatically, and then it will try to find it in our webcam. So to do that, as you can see here, we have the images attendance, and we have 3 people here: Bill Gates, Elon Musk, and Jack Ma. So what we will do is that we will ask our program to find this folder and find the number of images it has and import them and find the encodings for them. So to do that, we are going to use the OS. So we will write import OS, and then we will first import our images. So we will write here path is equals to images attendance, and then we will create a list of all the images we will import. So we will call this images, and then we will also write the names of all these images. So we will take the names of each one of them, and when we output the result, we will use these names. So instead of creating a new list where we have to manually type all the names, we can just take it from our image itself. So here we can write, let's call it class names. So the first thing we will do is we will grab the list of images in this folder. To do this, we will write my list is equals to os.list directory, and we will give it a path. So if we print this out, so as you can see, we have Bill Gates, we have Elon Musk, and Jack Ma. So we have all the 3 images. So next we are going to use these names and import the images one by one. So we can write here for CLS, which is our class in our my list, we are going to import each of the classes. We can use the load image, but here we are going to use the normal IMRead function that comes with OpenCV. So we can write our current image is equals to cv2.imread, and then we will read our current image, which is basically our path, and then slash, and then CL. CL is the name of our image. So for example, the first one will be billgates.jpg. So CLS class, or let's put it without the S. Then we are going to append, so we will say images dot append, and we are going to append our current image. And the last thing we will do is to append our class name as well. So class names dot append, and inside here we don't want to append just the name like this, because it's billgates.jpg. We just want Bill Gates. So to do that, we can write os.path.split text, and we want to split CL. and then we will grab the first element of it, which is 0. So this will give us Bill Gates instead of billgates.jpg. So we can print this out to see if it works properly. Class names, and let's comment this out. So as you can see, the list was like this before, and now it is without the extensions of the files. Okay, so next we are going to start with our encoding process. So we know that once we import our image, we have to find the encodings for each one of them. So what we can do is we can create a simple function that will compute all the encodings for us. So we can write here find encodings, and we will require a list of images. So images, then we will create an empty list that will have all the encodings at the end. So we will call it encode list is equals to empty, and then we are going to loop through all the images. So for img in images, so the first thing, as you know, we have to convert it into RGB. So we will copy this line. So our image is equals to image converted to RGB. Then the next step is to find the encodings. Now to do that, I think this part is done, so we can remove this. Let's go back to the basics, and let's actually copy all of this, and then we can paste it here, and then we can comment it out. So the next step is to find the encodings. So here you can see we are finding the encodings. So we can write here encode, and then over here we can just make it image. So this will find the encodings, and then we will just append it to our list. So encode list dot append, and then we will write encode, and at the end we will just return this, return encode list. Now to run this, we just have to call this function. So we will say encode list for known faces is equals to find encodings, and we will send in our images. Now to test if it works properly, we can print out the length of our encoded list known. So let's run that. And there you go. So now we can see we have 3 encodings in our list. So we don't need to print this, but what we can do is we can print whenever we have found the encoding, so that, because it takes a little bit of time, so we can write encoding complete, so we know it has done this step. So now we are moving on to the third step. The third step is to find the matches between our encodings, but we don't have an image to match it with. Now that image will be coming from our webcam. So let's initialize the webcam. So we will write cap is equals to cv2 dot video capture, and we will give it 0 as our ID, and then we will write a while loop to get each frame one by one. So here we will write success, and then we will write image, which is equals to cap dot read. So this will give us our image. Now because we are doing this in real time, what we want to do is we want to reduce the size of our image, because this will help us in speeding the process. So we will write that our image small is equals to cv2 dot resize, and we will send in our original image, and then we will We don't want to define any pixel size, and we will write none, and then we will define the scale. So the scale we will put as 0.25 and 0.25, so it is 1/4 of the size. And then as you know, we have to convert it into RGB, so we will copy this and we will convert it into RGB. And then the next step is to find the encoding of our webcam. So here we can copy this. Now in the webcam image, we might actually find multiple faces. So for that, we are going to find the location of our faces. Then we are going to send in these locations to our encoding function. So to find the locations, we can use this. So we can write here faces in our current frame, and then we can find all the locations in our small image. And then our encodings, we will write encodings of current frame, and then we will send in our small image, and along with that we will send the faces, the location of the faces. So faces current frame. Now we are moving on to the third step, where we are finding the matches. So what we will do is we will iterate through all the faces that we have found in our current frame, and then we will compare all these faces with all the encodings that we found before. So to loop through, we are going to use both of these lists, and to loop through them together we can write for. So the first thing we will find is the encoding, so we will write encode face, and then we will also find the location. So we can write in zip, and then we will write encodes of our current frame and the faces of our current frame. So what this basically does is, so one by one it will grab one face location from the faces current frame list, and then it will grab the encoding of encode face from encode's current frame. So because we want them in the same loop, that's why we are using zip. Then we are going to do the matching. So we will write here matches is equals to face recognition dot compare faces, and then as you remember, we have to send in a list. So the list of our known faces is basically encode list known, so we will send that encode list known, and we want to compare it with one of the encodings, which will be our encode face. So we will write here encode face, and then we are going to find the distance. So face distance is equals to face underscore recognition dot face distance, and then we are going to send in the same parameters. So encode list known and encode face. So because we are sending in a list to our face distance function, it will return us a list as well. So it will give us 3 values because we have 3 known faces, and it will give us the distance of each one of them. So the lowest distance will be our best match. So let me show you what I mean. So if I print face distance, this will be a list. I actually didn't connect my webcam. Let me connect the webcam so we can run this. So now I have connected my webcam, and as you can see, we do not have any output because we are not showing the webcam image. But if I bring my webcam near to a Bill Gates image, you can see that it starts giving us values, And as you can see, the value at the first element is the lowest. So because the image I'm showing is of Bill Gates, that's why we have the lowest one at the first element, and the second and third are for Elon and Jack Ma. That's why they are higher values. So what we have to do is we have to find the lowest element in our list, and that will be our best match. So to do that, we can write match index is equals to numpy dot minimum at our face distance. So this will give us the index. So in this case it would give 0 because this is the first element. If it was this, it will give us 1. So once we have that index, now we know which person are we talking about. So what we can do at the end is we can simply display a bounding box around them, and we can write their name. So to do that, we can write if matches, and then we can write index, match index, and then here we can write our name is equals to class name at our index. So match index, and because it's a name, we can convert it into capital letters in case the name is in lowercase. So we can write upper, and we can print this out. So print name, and let me run this and see what happens. So here if I bring the image close to Bill Gates, and it will say Bill Gates. So what we can do is we can create a bounding box around the face, and we can write the name. So to do that, let's first show the image as well. So we can write here cv2.imshow, and we don't want to show the small image, we want to show the original image. So we will write here webcam, and we will write here image, and then cv2.weight key is 1. So if I run this, there you go. So you can see that we have the image of Bill Gates, and it's giving us Bill Gates as the output. Okay. So in order to create that rectangle, we need to first find the location, and because we already have done that, because we have all the locations, what we can do is we can say y1, x2, and y2 and x1 is equals to face location. So this face location is basically this coming from our locations of our faces. So then we are going to draw a rectangle, cv2.rectangle, and we want to draw it on our original image, and then we are going to write here x1, y1, and then x2 and y2, and then we are going to give it a color. Let's give it green, so 255 and 0, and then we will give it a thickness of 2, and then we can draw another rectangle, cv2.rectangle, on our original image. Now this one will be x1 and y2 minus 35, and then this is x2 and then y2, and then 0, 255 and 0, and then this will be cv2.filled. Now this is the method that the author used. I'm using the same method to display because it has a rectangle at the bottom, and then it shows the name, which actually looks nice. So we are using the same method. So cv2 dot put text, and we are going to put the name. So we will write here name. Because the name is already in string format, we don't have to convert it. And then we will write here x1 plus 6, then y2 minus 6, and then we are going to write cv2 dot font. We will pick any font, and then we will give it a scale. Let's give it 1, and then we will give it a color. So let's give it white color. And do we need to give something else? Let's give it a thickness of 2. So if we run this, you will see we have a problem. So let's run that. So there we go. So we are detecting properly, but the location is wrong. And the reason for that is that we have scaled down our image to 1/4 the size, and then we are performing all these calculations. So in order to revive that actual values again, we have to multiply our value with 4. So what we can do is we can write here this equals multiplied by 4, then multiplied by 4, multiplied by 4, and multiplied by 4. So if we run that now, so there you go. So now it's showing it in the correct place, and it's showing the name as well, Bill Gates. And if we try out another image, so it's giving us Elon Musk properly, and then if we try another image, and it's giving us Jack Ma. So now we are able to detect all of them properly. So we can comment these out because we are already displaying. Now the next step would be to mark our attendance. So to do that, we can create a new function, and we will go up here. We will write here mark attendance, and all we need is the name to write down our attendance. So to mark the attendance, we will just write the name and the time that they arrived. Now you can experiment with this. You can add a lot of different things. You can even link it to a database, and you can do a lot of different things. But to keep it simple, we are only going to use name and the time they arrived. Now to use the time, we will need the library for a time and date. So we will say that from dates time import dates time. So we will be using this. So now what we will do is we will create an attendance file. So we will go here, we will create file new, and we will create a new file, and we will call this attendance.csv. CSV stands for comma separated values. So the values we put in will be separated with commas. So we will write that in, and we will ignore this, and then inside we will write name, comma, and then time. So these will be the two values that we will enter. So we will save this. Let me go back and save, and then we will go back to our attendance, and over here we will open this file. So we will say with open, we are going to open attendance, no, not this, attendance.csv, and we want to read and write at the same time. So we will say write plus, and we will say as f. Now we are going to read in all the lines that we have currently in our data. The reason for this is that if somebody is already arrived, we don't want to repeat it. So we will create a list. So we will say my data list is equals to f dot read lines, and we can print this out, my data list. So if I just call it here mark attendance, and if I just put a in here, and then if we run this, you can see it gives us name and time. So next we are going to go through this list one by one. So we will say that for line, in right now we only have one line. So later on we will have multiple lines. So we will go through each line and we will say my data list. We want to find the entry, so we will write entry is equals to line dot split. So we want to split them based on comma. So then we will have name and time separated. So name will be our first element. So we can write, we can create a new list here. We can write here name list. This will be an empty list, and we want to put all the names we find in this list. So our entry is basically two values. We just want the first one, so we will say name list dot append, and we are going to append the first element of our entry. So entry at 0. So entry 0 will be name. So it will append only the names in our list. So once we have the list of all the names, we are going to check if the current name is present or not. Name not in name list. If the name is already not present, then we are going to find the time. So we will say now is equals to date time dot now. This will give us the date and time, and we will only write the time. So we will write our date string is equals to the date and time string is equals to now dot string, and then we are going to write the format. The format is basically percentage hour, and then percentage minutes, and then percentage seconds. So then we can write f dot write lines, and we can write f, and then we always want to write it in a new line, so we'll put a new line, and then we will put curly brackets, and we will write in the name. Then we will write a comma because they are comma separated values, and then we will write in our time. So date time string, and there you go. So if I send in the name, let's say Elon, it should enter the value. So let's run that. So if we go to our attendance, and there you go. So it entered Elon, and it entered that at the current time 10:43 and 04 seconds. So now whenever we find the face, we have to call this function and give it the name. So we will remove this from here, and over here, whenever we are matching, we are going to send in to our mark attendance. So here we will just say the name, and that is pretty much it. So if I go back to what do you call the attendance list, so as you can see, Elon is already there. So even if I put the image of Elon in front, it will not do anything because it's already there. Now it will only mark the attendance for who is left, Bill Gates and Jack Ma. So let's show that and let's see how it works. So here we have Bill Gates. So we have shown Bill Gates, and then we will go to Jack Ma, and there you go. So if we stop this now, and you can see that the two new entries have been added. So you can see Bill Gates and then you can see Jack Ma. So this looks weird because we are not used to of reading tables like this. So if we go to our project directory and if we open this in Excel, it will look normal. So here you can see that we have the three entries at their given times. So the final thing we will look at is how easily can we add another class or another human being. So what we can do is, as you can see here, I have another image of Jeffrey Preston, and what I can do is I can just drag it in my images attendance, and that's it. So now it will be able to find the images of Jeffrey as well. So if I run this, now if I bring in the image, you can see that it has detected it properly. And if I close this and go back to my attendance, you can see a new record with the correct name has been added. So this is how easy it is to actually add new people. All you have to do is just bring in the images of whoever you want to add to this folder. So this is it for today's video. I hope you have learned something new. If you like the video, give it a thumbs up and don't forget to subscribe, and I will see you in the next video.